Hey everybody, this is Dr. A here, and in this video we're going to be providing some background information and some conceptual information on moving loads on trusses. Okay, so let's go ahead and get started. So in general, we know that many structures support moving loads. Okay, what are some examples of that? Well, the most obvious example of a structure that supports a moving load is a bridge. We also could have things like monorail systems as well, and even cranes, sometimes depending on the kind of crane, deals with moving loads across its members. Okay, so in particular, when analyzing a structure with a moving load, we are typically interested in where the load will cause a maximum effect somewhere on the structure. Let's think about that sentence for a second, okay? We are typically interested in where the load will cause a maximum effect somewhere on the structure, okay? So let's first think about what is this term maximum effect? In particular, what do I mean by effect? Okay, well, what that means is when we think of an effect on a structure, we think of things like external reactions or internal shear force, internal bending moment, internal axial force. Okay, these are effects. So let me change colors here and let's write that down. An effect may be a reaction. It could be internal shear force, could be internal bending moment, or could be internal axial force, etc. Okay, so that's what we mean by a maximum effect. Where, when you have a moving load, where on the structure will that load be located that causes a maximum effect somewhere on the structure? Okay, so for trusses, let's change colors again. For trusses, we are typically interested in what joint a moving load will be at when a particular member force will be maximized. Okay, so for example, if we have a truss here, and I'm going to draw kind of a general truss, okay? Let's say we have a truss with, some joints here. Let's say we have numbers across here, and we got a pin and a roller here, okay? And let's say that we label these members A, B, C, D, E, and F, okay? So in this discussion we're having, what we're talking about is, let's say we have a load that could move across this truss somehow, okay? where on this truss would that load be located that would maximize the force in, for example, member FE, okay? Where would this load be that would cause the force in member FE to be a maximum? Or where on this truss would this load be placed to cause a maximum force in member BE? We can keep asking this question. Where on this truss would this load be as it's moving along that will cause a maximum effect in one of these members? Okay, that's the question and the discussion that we're having. Okay, so how do we do this is the question. Okay, so in order to investigate this, okay, so to investigate this, what we do is we draw what's called an influence line for the effect of interest. Now again, what is this thing called an effect? We got to keep reminding ourselves when we say effect, it could mean an external reaction. If you have a beam, it could be internal shear force or internal bending moment. In this case, if we're dealing with a truss, we're talking about a member force as an effect of interest. A member force in one particular member at a time, okay? So this thing called an influence line is the following. We're going to say this is a graphical representation of a load effect as a function of a load's location on the structure, okay? And in particular, we draw influence lines. I'm going to abbreviate it as IL. We draw influence lines based on a unit load moving across the structure, okay? So what's great about this thing called an influence line is it can tell us where the moving load will be located that will cause the maximum effect or the greatest influence on a particular member. That's the idea of it, okay? And so how do we do this? Again, let's change colors. We're going to say place a dimensionless unit load at each joint on the truss that the real load is expected to be, okay? Then what we do is we use equilibrium methods to obtain the influence ordinates. Now, what do we mean by equilibrium methods? Well, the equilibrium methods when we talk about trusses could be either method of joints or method of sections. In this case, we're going to use method of sections, okay, when we actually do examples of this, okay? So the influence ordinates, will be the member force for a desired member, okay? And then what we do is we plot the influence ordinance versus unit load location, okay? So for a single real moving load, we multiply the influence ordinance by the magnitude of the real load. Okay, now we did a lot of writing here. My hand is sore from writing on this iPad. We did a lot of writing here. There's a lot of background information. No calculations yet, okay? So here's what I suggest you do if this is a new topic for you. Take some time, rewatch this video, write these notes down, and understand what I'm saying, okay? And then what we'll do is in another video, we'll do an example problem of us actually going through this process, okay? But it's important to have an idea of the vocabulary here. If we don't understand the vocabulary behind how this works, then it's going to make doing the calculations more challenging and, not as easy to understand, okay? So if you found this background information helpful on influence lines for trusses specifically, please hit like and subscribe and be on the lookout for other similar content.